Is it now recording? Okay, now it's recording. Okay, let's continue. The first one is gravitational force. We call that weight. We usually call that weight, and it is equal to mg. So g is equal to 9.81 meter per second square. So that is the weight. It always pointing downward. It always pointing downward. So be aware of the direction. Second force is, someone say that in the chat room already, is normal force. Normal force. So the symbol is usually called N. So please notice that this normal force is always perpendicular to the contact surface. So that is the second type of the force. The third type of the force is called the friction. Friction. It's more. So this friction is usually against the motion, opposite. Let's see what's the spelling here. More opposite to the tendency of the motion. So if the motion is going forward, surely it will be backward, right? But if the object is stationary, however, it has a tendency to go forward, there will be still a friction to prevent it from the motion. So that's why friction is always to oppose the motion, okay? And the last one, what is that?
Tension.
Tension, very good. Tension, and the direction is like always trying to restore its original length. Original length. So we have to be able to learn these forces and try to analyze the situation whether there is a force, how many forces are acting on one object, and by making use of these forces, or we call that free body diagram, we can solve the problem by telling, oh, what is the net force on it and how would it affect the motion later on. So let's go back to the previous part. Let me share the notes again. Oh, this is the notes, right? Now, so there were three laws. The first law is called the Newton's first law, right? So there is a statement here. We should be able to write down this statement by ourselves without referring to the notes. So it always, every object remains stationary or move at uniform velocity unless there is an unbalanced force acting on it, wrong spelling, sorry, acting on it. So if I make it simple, I can just write this net force. When net force equal to 0, it will be having uniform velocity motion. So notice that stationary is also a uniform velocity motion, but the velocity just remains 0. So we should also be able to give some examples on the motion related to Newton's first law. Whenever you see a motion that is having uniform velocity motion, I would say that they would be having a net force equal to 0 acting on it. There's no net force in on it. So for example, you should be able to give some examples like, why are we using a seatbelt? Because when we are driving or you're the passenger, you're constantly going in a certain direction. You're maintaining a certain speed. However, if the car may be hitting an obstacle, or suddenly we have to brake our car, so due to the Newton's first law, our body will keep the motion forward, so that we'll be leaving the seats and be able to hit the windscreen in the front. So that would prevent the seatbelt can provide just like keeping us to the seats and prevent us being thrown forward. So I would call this is the, it's due to the inertia, okay? The ability to keep our motion. Okay, you should also notice that there's a headrest. Imagine, this is so ugly drawing. Sorry, let me draw again. What I mean is like this. If you're sitting here, so if the chair is only up to your back and it's not supporting your head, so what will happen if suddenly you're being hit by something, when a truck is hitting you from the back? So you can imagine the chair would exert a force to the body so that the body would go forward suddenly. However, your head, due to inertia, will just keep stationary at where it is. So you can imagine the body go forward, the head staying here. So it would be having a damage on your leg. So this is why we need to put a headrest here, so that when you accidentally got hit by something from behind, your body and your head would be pushing forward together, so not leaving the head behind, right? So this is the meaning of the headrest. And the last one, another example is when you are traveling in MTR, where you're standing in a bus, when the MTR bus suddenly brakes, you will thrown forward due to the inertia also. So this is Newton's first law. The key is here always. Net force is 0. You'll be keeping the uniform velocity motion. Okay. Now let's continue. There's no red dots. What is that? Oh yeah. I fixed it already. Okay, then the second law is called Newton's second law. It seems I can't erase more than a row, isn't it? Ah yes, now it works. So what's Newton's second law? That is net force equal to ma. Net force equal to ma. But you need to understand the meaning of the term net. Net means we need to draw a free body diagram first. After we draw this free body diagram, we will be able to analyze how many forces is acting on an object. So in this situation, we may write two equations horizontally. Now, horizontally, what would be the net force? Net force should be equal to, now you see horizontally there are two forces, right? One is forward, one is backward. So we need to cancel that and see the remaining value. What should it be? Big F minus small f. Now we will be always using that in case of the forces acting on an object. We need to analyze that by doing free body diagram, and then look at the forward force minus the backward force, and it is equal to ma. Because if something is left on the surface, when you push it, it will go in this direction. This is the predicted motion with an acceleration. Surely it could be zero acceleration if the force is completely balanced by the friction. It could be zero. And apart from horizontally, we may also write another equation that is called vertically. Now, the object would not be leaving the surface or sink deep down through the surface, right? It's not possible. So that means net force in vertical direction should be 0, right? There's no motion in this direction, no motion. It's not going up or down. Then that means we may have this relationship. The normal force should be equal to the gravitational force. If we use the symbol we usually use, is N equal to W. So you can set up two equations, and it depends on what the information the question is asking. So you may just try to find the unknowns by using these two equations. There are two equations you can set up by yourself. This is one of that, and the other one is this one. Okay? This is Newton's second law. I'll roll here already. See? So this is the idea of Newton's second law. Let's continue. Oh, what happened? What happened? I pressed the wrong button. Now, so that now, since if net force is not zero, there will be acceleration. But if net force is equal to zero, it's just like uniform velocity motion. This is referred to the case of the Newton's first law. This is first law. So this is second law, I mean. There are only two possibilities, right? Net force equal to zero or net force not equal to zero. So that is how the Newton's first and second law talking about how would the forces affect a motion. Okay, so let's go on to the last case, the Newton's third law. Newton's third law. So in the Newton's third law, in fact, there will be always two forces in nature. I mean, the force would not appear alone in nature. It has to be in pairs. If you find one force, like A provide a force, A is acting a force on B. At the same, according to this is F, okay? In fact, B would be also acting a force, F pi to A. It's a must. It's just
so
like,
how about gravity?
It's the same, like gravity. The Earth is attracting you downward. But at the same time, you're attracting the Earth upward. But the Earth is too heavy. You don't see any apparent change in the motion. So this is the rule that Newton proposed. And the relationship between this action and reaction is F is equal to the negative F pi. Yes, black hole is also action-reaction pair, in fact. The black hole is much heavier than us. It's like, the mass is like few times of a sun or even more. So when it attracts something towards it, the black hole is also being attracted. But like what I say, it's too heavy, you don't experience any, you don't really see anything. Okay, so this is action-reaction pair. And the three conditions for these two forces, I mean F and negative F pi, they have the same magnitude. That means the sign should be the same. If I give you 10 Newton, you'll be giving me back 10 Newtons, the same thing, right? And the direction is opposite. The force I give you is forward, then you will be giving me a backward force. And these forces would be only involving two objects, okay? It's a matter between two people. It's not allowing like triangle relationship. I give you force and then you'll be giving me a force at the same time. This is called mutually acting on each other. So we see in this case, when the people, when the people step on the soil, on this platform, in fact, he would be kicking the boat backward. He would exert a force on the boat. This force is from people to the boat. However, at the same time, I use a blue color. Due to the Newton's third law, there would be another force acting on the people. In fact, this is the blue color one. The boat will also exert a force on the people so that he can go forward by this force. This is action-reaction pair. So like this case, this is a force A acting on B, and on the other hand, there will be another force B acting on A. It's just like providing force on each other. So quite likely there would be question asking a rocket. Oh, sorry, two people is waiting in the waiting room. Okay, now so two forces. In fact, there will be an explosion inside the fuel tank of the rocket, and the explosion will push the exhaust gas backward. This is the force acting on the exhaust gas, right? So at the same time, the exhaust gas would also attack another force to the rocket. It goes forward. So this is on the exhaust gas. And the blue, and the other one is, this force is on the rocket. So you may notice that it
Sir,
involves two objects. Yes?
there's no way to break this law?
No way.
Are you sure?
Up to our knowledge now, it has to be two forces. If you can break it, you can become another Nobel Prize winner, I believe. All right? But surely, if you talk about something deep down to the elementary particles, it is not really in the same sense. Okay, if you have the chance to study something like particle physics, you'll be learning something called gluon or something called Higgs boson, etc. That would be the origin of the forces. It's just like interchanging the particles instead of action-reaction pair. But it's go far beyond what you need to learn, right? So yeah, for most of the cases in our daily life, it has to be action-reaction forces involving two people. No force existing alone. Hola, so we will stop here first to do some questions on the motion of, I mean Newton's law first. And since there's one more chapter, actually I also make the notes already, but I don't think we will be having time to finish that today. I may try to make a video later so that you may prepare that during the Christmas holiday. Now, so let's start the questions we're going to do. In fact, these questions I also uploaded last time, and we go through the first 8 questions already. Okay, by accelerating laser pulse, someone says something, let me check. Okay, by accelerating laser pulse around a loop seemingly without any corresponding pushback. But this is not force. It's a transmission of energy. You don't need a force to, because laser is not a particle. Right? Do you agree? It's just like change the energy from electricity to electromagnetic waves. It's not really related to forces. Okay, now, so let's start the questions. Remember this type of question, we have been doing that when we are having the film lesson in Form 4. And also, yeah, we did that in some exercise and tests, but it's always happening in exam also. So in order to handle this question, what you need to do is to draw a three-way diagram. Now for object X, there will be how many forces is acting on object X? Let me ask some questions. Lusaiba, how are you? Can you tell me how many forces is acting on X? Now I give you hints. This is what we have learned. We have learned weight, tension, normal reaction, and friction. Huh? Come on. Now just answer me one by one. Is there weight acting on X? Hello? Yes, good. Because it has a mass, right? So the weight is always pointing downward. Sorry, is there any tension? For tension, you need to see whether you have a string. Yeah, good, good. Someone also answered me that. Weight and tension. Now, normal reaction, is there any object in contact with it? So it's only a string. So that means there should be no normal reaction. And since there's no contact surface, there's also no friction. So you may think in this way. This is what we have. Secondly, I will do the same thing on Y. It's the same. It's the same. It has a weight, although leaving seats are just kidding, just kidding.
Sir, what about the friction around the circle?
The pulley, right?
Yeah.
It could be a friction there, but the question say that is a smooth pulley. So we may just ignore that. Good question, huh? So there's another side. You also have tension and the weights, yes. Now to distinguish these two weights, I call it WX and WY. But tension should be the same because they are at the same strain. They are the same strain, so that's why I just put them, they should be having the same tension. Now, so once we have that, you may have a look, Y is heavier, so that Y should be going downward, but X should be going upward. Immediately, we can set up equations for object X and Y. You may just do the same thing like this. Whenever you see a question involving two objects, they're linking up together by string or in contact, you may just set up the free body diagram. And you may do like this, like X is going upward, right? So the net force will be tension minus WX, which is equal to MA. This is the first equation I can write. Or you may just substitute the value 3 times 9.81 equal to 3A. So what I did here is to put the mass of X. This is 3 kg. And weight is simply mg, right? This is what we have done before. Now, so you set up one equation already. Make sure that you know how to set up this equation because it is the skills we will keep using when the question involves the force. Okay, for Y, I will do the same, but now Y is going downward. What I have to do is to do that in the opposite way. It should be the upward force larger than the downward force larger than the upward force. So the WY minus T is equal to MYA. Then it's 4 times 9.81 minus T equal to 4A. So that's, yeah, we got two equations now, right? Equation 1 and equation 2. So what can we do? We try to find the value of A, right? That means you want to eliminate the other unknown. I want to eliminate that. By eliminate that, the method is to add these two equations together. You may add this equation 1 and equation 2 together. You may find that when you add them together, you will cancel the T. All right, so let me do it on the left top corner. Let me erase this part. Oh, I pressed the wrong button again, so stupid. Now, so let me erase this. I will do it here. Now, just do like T minus, now 3 times 9.81 is, let me calculate that. 3 times 9.81 is equal to 29.43 equal to 3A plus, oh, sorry, it's 5. Thank you for reminding. So, I'm so absent-minded. Thank you for reminding. It's 5. Someone say that or before, maybe I don't really get that. Okay, 5 times 9.81 is equal to 49.05 plus T equal to 5A, right? So you may add them together. Sorry, mistake again. So don't be careless like me. It should be minus. So when you add these two together, the T can be cancelled. because t minus t is 0. So that would become 49.5 minus that. Okay, so it will become 29.43. So it becomes 19.62 equal to 8A. So when you add that together, you will have this number, and the answer should be equal to, you just divide that by 8. It's 2.45. The answer is 8. Okay, very typical question. So we take a 5 minutes break and then we will continue. Okay?
Sir,
Yes.
is that will be in the Google Classroom?
Well, let me this file. This file
Yeah.
is already there. Last lesson.
Sir, Alex is in the waiting room.
Oh, I became just now. Thank you for reminding. Okay. So that's the first question. So let's continue. Okay, second one. This one is a bit easier. So Diana is standing in the lift, and the lift slowly moves down uniformly with a acceleration downward, 1 meter per second. So let's say this is Diana. Okay. So there's a weight. And surely when she's standing in the lift, apart from the weight, there would be also a normal force acting on her. So only two forces, right? Since it's going down uniformly, so I will write down the net force using the downward force minus the upward force, and which is equal to MA. Now that is the equation we have. I think it's not difficult for this, right? If you can draw the free-body diagram and be able to get these two forces, you can write down this equation easily. W minus N to MA. So after that, you may just put the number 50 times 9.81 minus N. This is the force you're looking for. The magnitude of the force acting on the weighting scale. In fact, we can also we can only measure our weight by the normal force acting on you. Okay, this is the measured weight. This is the value N. You look for the N, and it should be equal to mass times acceleration is 50 times 1. So in that case, it would become 490.5, isn't it? Minus N equal to 50. So now you may just change the variable. N goes to the right hand side, right? So it will become 9 minus 50. Okay, you just interchange these two. So that it will become 440.5 Newton. So that's the answer here. You will apparently feeling lighter when you are accelerating downward due to the calculation here. This is the calculation we got. Okay?
Sure.
Yes, question?
Sir, because the lift is going up, that means that's normal force.
If the lift is going up, that means we should do it another way. If the lift is going up, we may do like N minus W in that, because we should use the upward force minus the downward force if it go upward. And it's also equal to MA. So you may see that N is equal to W plus MA. You got heavier. You become larger, N become larger than W if it goes upward. Going upward with acceleration. So that's the difference. Just like if you're at ground floor, when you go up, in fact, you feel heavier at the beginning. Is that clear?
Yeah.
Good. Okay, let's go on to the next question. Number 11. Okay, let me erase the board first. Okay, now there is a force acting on the block on a rough surface. First 5 seconds, the force is equal to 7 Newton forward. 7 Newton forward, right? And after that, you'll be doing a force backward, -3. So in order to understand the situation, we may draw a free body diagram for t equal to 0 to 5 seconds. The force we add on that is F equal to 7 Newton, and then a friction, isn't it? So that net force is equal to 7 minus F equal to MA. So that is the information we got. We know that it's accelerating because the friction is only 5. So that means 2 equal to ma. And m is equal to 2 also, right? So that means 2 equal to 2 times a equal to 1. Now, so it will be accelerating. It will be accelerating. So we may have a look on the later. We look at that later. We keep this information first. For the first 5 seconds, if accelerating forward. Okay, but at t equal to 5 to 15. Now, so what would be the net force acting on that? Now the object is moving forward. It's still moving forward. That means the friction is going backward. However, the force would be also towards backward, equal to 3 Newton. Is it 3? Let me check. Yes, 3. Negative 3. Negative 3 means backward 3 Newton. Okay, now so this is 5 Newton. So totally, the net force is equal to backward negative 3 minus 5. Both forces are going backward, so that's why both of them are negative, and equal to negative 8 Newton. And also it's equal to ma. No, still not enough space. Can you still see that? Yeah. So that means A is equal to negative 4 meter per second square. Now, so this is what we have. At the first few seconds, we got A equal to 1. And later on, it will become A equal to negative 4. Now, so I will scroll down a little bit to check the options you provide. So which one is the most likely answer? We may cross out B first. You may see that the slope here, the accelerator is looking at the acceleration. The slope should be equal to 1. Because A is equal to 1, that means in each second, it will just increase by 1 meter per second. So this is absolutely wrong. It's too fast. The rate of acceleration is too fast in this graph. But for all these 5 seconds increased by 5, these 3 with a correct segment in the first part. Okay? And the second thing we should be able to tell is which of the following would be correct. Now, since the calculation we got is negative 4, that means this is not correct. You know that it takes 5 seconds to decrease by 5. So that means in this graph, we got A equal to negative 1 only. But now the calculation we got is having negative 4 deceleration. It's way far more steep. It decelerates much faster, so this is wrong. Similarly, this one is also wrong. It takes 5 seconds to drop by 5. That means it's also A equal to negative 1. So that is also wrong. The only answer you can pick is D. So it dropped much faster, isn't it? And after that, the friction is only 3. It can't overcome the friction that is 5. You just stay where it is. Is it okay? So this question is a bit difficult, but the concept is still the same. You need to set up the equation like that. The net force equal to ma for both cases, since the force are changing given time. So that's the answer for the question 11. So let's go on. Oh, these 2 questions are relatively easier because it tests the concept instead of asking you something about the calculation. Which of the following phenomena can be explained by inertia? Inertia means the ability of an object to keep its motion. Okay, so first, a passenger in the MTL tends to move backward when the train speeds up. Is that correct? Just like when you stand here in the train, if the train go forward, you have a feeling that you lean backward, right? So it's correct. It is the answer already, right? But the other things are not actually related. I will not go through that. You may have a look on that later on. So answer is simply A. We mentioned that in MTLs, when you brake or you start suddenly, so we will feel the inertia. And question 13 is the question asking action reaction pair. When you think about that, always remember the three keys. They have the same magnitude, right? Secondly, opposite direction. Number 3, on each other. They should be involving two objects, and the ball would be like having to be like acting on each other. So now, is a man hit a volleyball? You don't need to look at the option given. You should choose, you should know that the answer should be the volleyball providing a force on the man. Volleyball on the man, right? It's like mutual, hitting each other. So yeah, the answer should be only one of that. It's D. The force F and the force acting by the volleyball on the man's hand, right? This force F is ball, sorry, man on ball, and this is ball on man, so that's why it's acting on each other. There's no other force that could be the reaction force on it. Okay, let's continue. Okay, this question is about a rocket. So find the lift off thrust. This lift off thrust is the force acting on the rocket by the exhaust gas during the explosion. So let me draw the rocket. So how many forces enter in it? There's only two forces. First, the weight downward. Another one is the upward U. So now if the acceleration is 12 upward, 12. What we can do is again, net force equal to MA. Net force equal to, now net force should be upward force minus downward force, upward force minus downward force. So U minus W equal to MA. So let's find, we're looking for this value, right? We look for U. So U should be equal to W plus MA, so that it would become, that this one is 600,000 times 9.81 plus, again, MA, A is 12. There's a 1 here, 1. So that is the way we handle this question, right? So you may just use your calculation. 21. Okay, so that's the answer I got. So you may pick B. Is that okay? So these few questions are the typical question like that could be asked in examination. So you must be able to handle that. If you have question, you may just like ask me anytime. Except the day before, the night before the examination. Don't have a habit like you always ask questions. Oh, sorry. Thank you for reminding. It should be D, not B. Very good. Always reminding me for my stupid mistake. Yeah, sorry for that. It should be D, yes. Because according to my calculation, there should be up to 10 to the power 7, but not 10 to the power 6. Thank you. Next question. Next question. It's a short question. One more question. Maybe you may see. So now this question is saying a very simple situation. I have a force forward 21 Newton, and there is a friction acting on it. In fact, there is also weight and normal force, but sometimes we don't need to care about that because we are talking about horizontal motion only. So you just look at these two forces, and then I'm set up the equation: net force equal to forward force minus backward force, which is 21 minus friction equal to MA. Do you familiar with that now? I hope you can really be able to write this equation by yourself. So yeah, because when you look at my my work, it's so easy, right? But usually when you do that, what's that? It seems I learned that, but I don't really know how to do it. Yes.
Can you also send us the recording video in the WhatsApp group?
Yeah, I won't send it in WhatsApp group, but I may put it in YouTube and give you the link.
In YouTube? You have a YouTube channel?
Yeah, I have a YouTube channel, sure, yeah. Yeah, you don't even know that.
I don't know actually, sir.
Okay, so that's why 21 minus F equal to 3 times 4. The mass is 3. The A is 4. So you have 21 minus F equal to 12. So that F is equal to 21 minus 12 equal to 9 Newton. I think the most important, I always stress on that, is whether you can write this equation on your own. If you can write this, the remaining will become only simple math. But if you fail to write this equation, I don't think you had a chance to overcome the question. Because that is the physics behind this is Newton's second law. You're actually applying the Newton's second law in different situations. It's so powerful. Newton's second law can help us to analyze almost all situations in your daily life involving motion. Okay, so this is how we predict the motion. Okay, that's the end of the question 15. It seems no more short MC question. We got short questions in fact. Okay. This is another question. Let me make it smaller. I need more space to write. Okay, a car of mass 1500 kilogram stopped on a rough surface with an engine problem. So the driver need to push the car horizontally by 800 Newton to restart that, and the speed would change from 0 to 0.6 meter per second in 3 seconds. So draw all the horizontal forces acting on the car. So so easy, right? Oops. So the car is like this. See, I'm spending time enjoying a nice car. Oops, failed. It's okay lah. You know what I'm drawing. So there will be a pushing force, 800 Newton forward. And there is another force backward, which is a friction. That's it, 2 forces, right? Horizontal forces only. You don't need to care about the normal force and the weight, only 2 forces. And secondly, what you need to do is you find the friction, right? So that means you need to write equation like net force equal to forward force minus backward force, which is 800, minus friction equal to MA. So that is the variable you're looking for, which is this one. You're looking for this F. However, you may see from the question, from the equation, I mean, there's two more unknown. Do we have M? Yeah, we have M here. Do we have A? I don't have the A right now, but what we have is this information. U equal to 0, V equal to 0.6, T is 3. So what is A? I can calculate A from the information given. When you have no idea on how to handle a question, read the question again and see what numbers you didn't use it yet. So that's the number you didn't use yet. So it's given there. So that means sometimes, I think like maybe 50% of the cases, you still need to use the concept of motion. So that's why I put chapter 1 and 2 and 3 together when we're doing revision, because they're always related to each other. You need to apply the concept of motion to handle a force. Okay, A, you're looking for this, right? It's equal to U plus AT. So which is 0 plus A times, oh, see, what I'm doing? I'm doing mistake again, it's V. Sorry, it's V. 0.6 is equal to, this is V plus this is V equal to U plus A times the time, which is 3 seconds. So that A is equal to 0.6 divided by 3. Isn't it? And you just cancel the 0. So which is 0.2 meter per second squared. Now, so once we find the A, we just like going back to the equation here. This is where we can find the value of F. Once we got these two information, I can find that. So it will become 800 minus F equal to 1500 times 0.2. So that is 800 minus F equal to 300. Okay. So F is equal to 800 minus 300. So answer 500. All right, that is the method we find the fraction. F equal to 500. Okay, this is the way we handle this question. Okay, a few more minutes. I hope we can do one more questions. One more question. Question 2. Okay, let me erase the board. A sailboat 300 kilogram, and with a rope connecting a rolling boat. So if the sailboat accelerates at 0.5 meters per second, show that the tension has to be larger than the 150. Okay. Now, we may consider the free body diagram on the rolling boat. This is a rolling boat. There are two forces acting on it. First, there will be a tension pulling it forward. And at the same time, it should be water resistance. It's just like friction, right? Since these two objects are connected, if the sailboat is accelerating with this value, so does this rolling boat. So what we can write is net force for the rolling boat. Net force is equal to tension minus friction, or water resistance, equal to MA. So that tension minus F is equal to 300, is given here, the rolling boat, times 0.5, which is equal to 150. So then the tension is equal to 150 plus water resistance. So you see that this value has to be larger than 150, right? So that's why you may conclude that the tension should be larger than 150 due to the water resistance. It's okay? Now, so yes, question.
I said yes.
Huh?
Yes, sir. Yes.
Yeah, thank you, thank you. Now, so that's how we handle the part A. And part B, what will happen if the sailing boat, a rolling boat, if the sailboat stops suddenly? Now, if the sailboat stops suddenly, the rope would be having no tension anymore. So what will happen if there's no tension? You will just check with the free-body diagram here. When the tension is no longer existing, there's only water resistance, isn't it? So the water resistance is opposing the motion. That means it would be slowing down the rolling boat. So what would happen eventually depending on the initial speed of the rolling boat? If rolling boats and the sailboat are really moving fast at the beginning, even though the rolling boat is slowing down, it would be having a chance that it will hit the sailboat because it don't have sufficient distance for it to stop. Do you agree? If the resistance is not large enough, the rolling boat may just hit the sailboat at the end. But if the water resistance is big enough and the rolling boat is originally moving slowly, it would be just like stop eventually in front of the sailboat. There were two cases, two possibilities, depending on the original speed of the rolling boat and also depending on the value of the water resistance. Two factors affecting the result. Okay, so let's see. I don't think we have time to finish the next one. We have only one more question here. I try to describe this a bit so that you may try to understand what's going on. I put a ping pong ball into a tank of water. That is the speed of it. Originally, the speed is high. Then it was slowing down until this point. The speed becomes zero. Just imagine when you throw something into water. When it comes to at rest, eventually that means it reached the maximum depth. Understand? It goes downward, but slowing down. But for this case, it reached the maximum depth, and then it would be starting to flowing up, going up, and getting faster. Gain speed. It's due to the floating force. Right? You know the ping pong ball is lighter than water, so it will be flowing in the water. So in handling these questions, it's like free-body diagram again. There will be two forces, the weight and the upthrust due to the floating ability. So it's always the upthrust larger than the weight. So that's why the net force is always equal to W minus U equal to MA. But this U is larger than W, so that A is negative. The upthrust is larger. So that's why you can see a negative slope here. Okay? We can find the maximum depth by looking at this area, how far it can reach. So that is the question about. You may try that by yourself later. So that's the end of the lesson. We still have Monday. Monday we'll talk about energy. And for the book 3A and 3B, you need to do it on your own derivation because it's just like we recently learned that, and we have a test before also, right? Now, so since there will be a holiday, and when we come back, we will be having a test Very fast. Let me finish that as soon as possible. So we'll be having a test on the 6th of January. Periods 8 and 9. I will upload the questions. I will upload the questions to the Google Classroom, and then you need to do that on the single line paper, and then upload that immediately. You will have 45 minutes to finish the test, and then you have 15 minutes to upload the file. I will keep checking to ensure that you can finish that. When will we come back? I don't know. It depends on the government. But you know, Form 5 Form 6 is having a lesson right now in the school. So during the examination period, we may try to arrange like separate form, different time coming back for the exam. So that's the arrangement. That could be the possible arrangement. It's not confirmed, right? It's just like I heard about some rumors. Also from other school, the teacher from other school proposing such arrangement. Okay? You saw me yesterday, where is it? Okay, now so let's, in computer room, yes, we are having a meeting. We will be having a renovation on 4th floor. That's why you see a new computer room next year. Okay, bye-bye everyone. So you may switch to the
Bye,
other.
sir.
Take care, bye-bye.
Bye, sir.
Bye-bye.
Bye, sir.
So always
Bye,
let me know if you have any questions. Bye-bye.